Let's discuss part 7 of structures and functions. In the previous presentation, we have learned how to pass array of structures as argument. Now in this presentation, we will learn what are self-referential structures. So let's get started. The definition of self-referential structure is very simple. Self-referential structures are those structures in which one or more pointers points to the structure of the same type. This is the simple definition. And here you can see this is an example. Struct self is the structure which consists of two members. One is an integer variable p and the other one is a struct self star ptr. This is the pointer to the struct self itself. You can see that is why it is called self-referential structure, because here we have one or more pointers pointing to the structure of the same type. So this pointer is pointing to the structure of same type, that is struct self. That is why the structure is called self-referential structure. Here we have a pointer which is pointing to the struct self itself. Now let's consider one example. Here I have declared a struct code which consists of these three members. One is an integer variable I, the other one is a character variable c, and then we have a pointer which is pointing to struct code itself. Now in the main function, I have declared a struct code var1. Basically this is a variable of type struct code. As we know, this is a variable of type struct code, so it can access all these members without any problem. So here you can see var1 is accessing these members one by one. First, it is accessing this variable I and is initializing this variable by this value, that is 65. After that, it is accessing this member c and initializing this variable by this character a. And then it is accessing this pointer ptr and initializing this pointer with null. Initially, this is the case. Variable var1 is accessing this pointer ptr, which is a pointer to struct code itself, but at the end of the day, it is a pointer. It contains the address, right? Initially, it is containing null. Now, let's visualize how var1 will look like. Now, this is the visualization of a structure which consists of three members, right? var1 is a variable of type struct code. It consists of three members, and here is how this var1 is initializing the members. The first variable has been initialized with this value, the second variable has been initialized with this value, and as this is a pointer, so it has been initialized with this null. After this visualization, let's move on to our code again. Now here I have declared another variable of type struct code. And with the help of this variable, I am initializing these members one by one with different values, of course. Here var2 is accessing variable I and is initializing this variable with value 66, right? And the rest of the members have also been initialized here. You can also visualize this in this way. This is how var2 looks like. Now let us suppose that the initial addresses or the starting addresses or the base addresses of these two structures are 1000 and 2000. This is my assumption, of course, and it could be anything. I'm assuming that these are my starting addresses. Now, here in this code, I have added one more line. I want you to focus on this line. This is var1.ptr equal to ampersand var2. Previously, var1.ptr has been initialized with null. Now here with this step, I am giving the address of var2 to var1.ptr. So what does it really mean? var1.ptr will now contain the address of the var2. We know the base address of this var2 is 2000, so it will contain this address 2000 here. As it is indicated that var1.ptr equals to ampersand of var2, which means that I am asking the address of var2 and I am storing this address here in this var1.ptr. That's why I have stored this address over here. After storing this address, of course, we can access this var2 easily with the help of var1 as well, because var1 has an address 2000, which is the address of var2. This means that var1 has the capability to access var2. So I have represented this relationship with this arrow over here. This means that var1 can access var2 members as well. That is why in the printf function, with the help of var1, I am trying to access the members of var2. Here you can see I have written var1.ptr, which means I am calling var2, right? Because var1.ptr contains the address of var2. So I am basically calling var2 and I am trying to access the member I of var2. And here you can see I'm accessing the member C of var2. This is very important point, let me tell you. With the help of var1, I'm trying to access the members of var2. Obviously, this arrow operator is required because this is a pointer. With the help of this arrow operator, I can directly access the members of var2, right? Here you can see I'm accessing the member I of VAD2 and here I'm accessing member C of VAD2. So the output of this program is 66B. You can understand that I have declared two variables of type struct code. With the help of first variable, I would be able to access the contents of the other variable as well. There is no problem at all. So why this is possible? Because here we have a struct code which consists of a pointer pointing to a struct code type of data only. That is why I have declared two variables of type struct code, and I have intentionally stored the address of var2 within var1 pointer. You can see over here that var1.ptr is containing the address of var2. This is possible because I have declared a pointer of type struct code. This is what self-referential structure is all about. Now, let's discuss how is it useful, how self-referential structures are useful. We will see the usefulness of self-referential structures in linked list. We will see how useful these self-referential structures are when we will discuss this topic, linked list. Okay friends, this is it for now. Thank you for watching this presentation.